Hi guys, today we will be continuing with the flavor chemistry lecture. In the last lecture, we have seen some of the initial discussion on the flavors chemistry. Now we will be taking into account the detailed chemistry of the flavoring substances. So look at this reaction. I have talked in the previous lecture that the L-cysteine amino acid in the formation of the sulfoxide that is important flavoring substances. Now we will be looking at the chemistry of that. So this is basically L-cysteine. It's an amino acid. You know that the amino acid, you are well aware of the cysteine structure. We have seen these proteins and the amino acid structure in previous lectures. So you know that the amino acid that consists of a COOH and NH2 group, right? So this is basically L-cysteine and that is combined with S1 propanol. Propanol means three carbon, right? So look at this one. This S1 propanol, this is the part S1 propanol, three carbon, one, two, three, and this is the sulfur. So this will be S1 propanol L-cysteine sulfoxide. This is the compound that is naturally present in onion. So with this compound, another enzyme that is present in onion, that is the alliinase. Alliinase. This is the enzyme. So this enzyme that is acting on S1 propanol L-cysteine sulfoxide and producing two kind of the substances. Actually, this is going to break the substances at this position, right? So first of all, removing this nitrogen containing substances, cutting it from this point. So this part is separated and this part is separated. So you look at this one, this part is actually the pyruvate. This is also separated, and this part is forming the 1-propenyl sulfenic acid. 1-propenyl sulfenic acid. And this 1-propenyl sulfenic acid that is actually converting to thiopropanol SXI, right? So there is actually the change of the position of the double bonds in this one. So that is the actually the major component that is providing the onion flavors. So it's a chemical type of the process. All of these presence of the 1-propenyl sulfenic acid, presence of S1 propenyl allyl sulfoxide that are present in the onion. And if you are making the artificial onion flavor, you have to focus on this one. This compound, and S1 propenyl L-cysteine sulfoxide to make the artificial flavors of the onion. So this is important. So the next flavor that is the formation of the garlic flavor. Again, another sulfoxide in the form of S2 propenyl L-cysteine. Again, it's a L-cysteine, it's an amino acid. It's an amino acid. This is an amino acid, right? This. And this is the propenyl. And this is the S2 propenyl now. So again, the alliinase enzyme that is acting on it, separating nitrogenous part, separating this L-cysteine part, but now that is actually combining with some part of the astropropenyl L-cysteine sulfoxide. So in this case, in the case of the garlic, that is some molecules that is in combined form. So thus forming the diallyl thiosulfinate. That is actually providing the flavor. This component that is not providing the flavor, that is now separated. This diallyl thiosulfinate that is providing the flavor of the garlic, and technically that is called as allicin. And as I told you earlier, that is composed of sulfur containing substances. Sulfur containing substances mean presence of the thio group, presence of the thio groups, right? So these are the two onions and the garlic flavor, onion and the garlic flavor. Now we are looking at another third flavor, that is from the crucifery family, flavor from the crucifery family, and that is allyl isothiocyanate. Again, there's a sulfur containing, thio means sulfur containing, right? So that starts with the allyl glucosinolate content. This is a glucose, you know, it's a glucose that is combining with the thio group, S group, thio group or S group. Then CH2 double bond CH, CH2 CN. So it's a nitrogenous group combined with again the thios group, SO3, SO3. And it's a potassium salt, SO3K, right? So attach a glucose with the S and S with SO3 combined with the nitrogen. So nitrogen and the sulfur groups that are available. So an enzyme that will can break the carbohydrate, separate the carbohydrate C6H12O6. It's a glucose that can cut it from here. This enzyme that will cut it from here. Maybe it's a glucosidase, right? So all the structure that will be the same. This structure that will be the same, excluding the glucose unit. We have cut off the glucose unit. So this will be the substance you are getting, excluding the glucose unit. So that is making two kind of the substances when this KHSO4, this has been removed. This has been removed, right? So what is the case? There are two kind of the substances that will be made. One of the substances that will be comprises of this one, CnCH2, CH, CH double bond CH2, right? and other will be containing this whole. Other will be containing this whole substance. So this whole substances that is called as the allyl thiocyanate, and without this sulfur that will be allyl nitrile, C double triple bond N, CH2, CH double bond CH2, right? So this is a typical crucifery flavor. Then we will be talking about some of the aldehyde substances that are actually derived from the fatty esters, fatty acid. You know that the fatty acids that have COOH on one terminal and CH3 on the other terminal, right? And these are the two double bonds. First double bond, second double bond, third double bond. So it's a molecule of the linolenic acid C18-3, right? So you are well aware of the lipoxygenase enzyme. You are well aware of the aldehyde type of the substances, right? So that is actually breaking down these fatty acid into hexanal. Hexanal mean Al ending, that is an aldehyde. Hexanal mean 6. Hex mean 6. So aldehyde, you know that the aldehyde have an ending of COH. We have seen in the carbohydrate structures as well. CHO, it's a 6 carbon compound. Hexanal mean it's a 6 carbon compound. So the first carbon will be CHO, second, third, CH2, 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 and terminal is the CH3, 6 carbon at the six. So it's a 2T. At the second carbon, it's a trans structure. So another structure that will be formed, that is the 9-nonadienal. Having dienal mean there are two double bonds. Enal mean it's an aldehyde structure. This is the aldehyde structure CHO, C double bond OH. Nona mean 9 carbon. This is a 9 carbon chain length CH2, and there are two double bonds at second position and at sixth position. The second position is a trans. This is a second position. It's a trans type of the molecule, and at the sixth position, this is the sixth position, it's a cis type of the double. So lipoxygenase is involved here, and the aldehyde lyase mean breaking down. Lyase belong to the enzyme that is going to break down the molecules. So that is an important flavor component in fresh tomatoes, and 2-D-6-C nonadienal, that's a important flavor component for the cucumber. So you can produce it artificially. If you want to produce a fresh tomato type of the substances, you will start with the linolenic acid and will produce 2-D-hexanal. That will be tomato flavor. Now you can add this component in some tomato purees, tomato ketchup, tomato powder, or so on. If you're working, for example, with cucumber pickles, you can develop this substance and add in the cucumber pickle. So these are the conversion. Further, the substance for the case of the cucumber, we have looked in the previous slide, 2-T-6-C nonadienal, that can be oxidized. So you know that when the aldehyde groups that are hydrogenated, reduced through the dehydrogenases process that can produce an alcoholic group. So this aldehyde group that can be converted into alcoholic group through dehydrogenase. What this dehydrogenase is doing? That is doing the oxidation reduction reaction. Here in this case, this is an reduction type of the reaction through the alcohol dehydrogenase. So beta oxidilinoleic acid are the fatty acid that can undergo the beta oxidation process, and you know that the beta oxidation process, that is uh, breaking a fatty acid by two carbon component separation. You know linoleic, it's a 18 carbon fatty acid. So when beta oxidation take place, this 18 carbon fatty acid that will be break down into 16 carbon chain and 2 carbon chain, right? So this is a 16 carbon chain linoleic acid that undergoes the beta oxidation process and producing an 16 carbon component or along with COA, acetyl COA, right? And that undergoes another reaction that is producing the ethyl deca 2T4C dienate. It's a pear-like flavor. It's a pear flavor. Now we will be looking to very important process of flavor development. That is one is called as the apple flavor and other is called as the banana flavor. So both of these flavors that can be generated in the labs as well uh, by the amino acid. And what is that amino acid? That is the leucine. You know, leucine is a branch chain amino acid. What is the structure of the leucine? We have seen already the structure of the leucine when we are talking about when delivering the lectures on the proteins and the amino acids. So leucine, it's a branching. You can see here the branching of the in the leucine. So on one end COOH, on other end NH2, and the R group comprised of CH2, CH, and the branching of CH3CH. Right? This is the leucine. So there are two fates. We will first of all we will be looking the apple-like flavor. So leucine that undergoes the enzymatic action that will remove the decarboxylation reaction. So decarboxylase enzyme that should be there, and this nitrogenous substances that have a very bad smell that should be removed, right? So carbon dioxide that is removed from here, and this should be nitrogen that should be also going to remove. So what will be the substance we have? This will be the component we have, right? Along with the C, right? So what we will have without this carbon dioxide and NH2, we will have aldehyde group. C double bond OH, it's an aldehyde group. C double bond OH, CH2, and this branch of the leucine. Okay. Yes? So it's an aldehyde type of the substances. So along with this removal, there is an oxidation process. So there will be an oxidase enzyme should be there, or it may be a chemical oxidation process. So this compound, aldehyde compound, that further undergoes an oxidation process, maybe an enzymatic process or the chemical process. So we already know when aldehyde undergoes an oxidation process, as a result of that, carboxylic acid is generated. We are simply adding one O, COOH. So this is the basically an acid development through the oxidation process. It's an acid to element through an oxidation process. So this is said when treated with the ethyl alcohol addition that will produce ethyl 3 methyl butyrate. Ethyl 3 methyl butyrate. So look at this one structure, right? And this is the ethyl. What is the ethyl alcohol? CH3, CH2, and CH3, CH2OH, CH2OH. This is an ethyl alcohol we are adding in this system. So this is the actually the coming from the ethyl alcohol, right? And this part will be the same. C double bond O, CH2, C double bond O, CH2, CH, and the branching. C double bond O, CH2, CH, and the branch, right? And this part is actually coming from ethyl alcohol. This ethyl alcohol. This ethyl alcohol. What is the structure of the ethyl alcohol? This is the structure of the CH3, CH2OH. This is the structure of the ethyl alcohol. So it's the formation of the 3-methyl butyrate. It's an apple-like flavor, apple flavor actually, right? When we talk about the banana-like flavor, we will again start with the leucine. The whole structure and the reaction will, at this point, that will be same. Here B undergoes for an oxidation process. But after this step, when the carbon dioxide and the ammonia has been removed, we are going for an reduction process. Here we goes for an oxidation process. Here we are going for a reduction process, means addition of the hydrogen. Where this addition take place? Again at that point. So all of that structure, this structure, that will be remaining the same. This structure, only hydrogen will be added on that. This structure is the same and the hydrogen is actually added at that point. So what it becomes when the hydrogen CH2OH, it will be formed CH2OH, and this structure remaining, this structure that will be the this structure that will be the same. This structure that will be the same. Only changes take place at that point. So now you know that it's an aldehyde substance. Now that is converting into alcohol, CH2OH, alcohol. OH mean alcohol. So after that structure, acetate, when we are treating with this acetate, this is the acetate, right? So that will be forming the isoamyl acetate, and that will have the banana like structure. So this is the addition of the acetate. This is the addition of the acetate, CH3, C double bond O, and this will be the same structure. This will be the same structure. This is the, you can see here the branching. This is the same structure, right, as this one, right? So this is the mechanism for the formulation of apple-like flavor and banana-like flavor. Then we talked about the citric acid. So there are so many, basically these are the fermentation products from the lactic acid bacteria. You know, the dairy product that is a source of the lactose. and that is converting into the lactic acid. So this phenomena actually exists in most of the dairy products. So from lactose, lactic acid is formed. Another pathway is that the glucose that is turning into the pyruvic acid and then into the lactic acid. And this pyruvic acid that have so many fates that will be coming from the oxaloacetate, and further that can be turning into acetaldehyde and acetolactic acids. So with acetolactic acid that is forming acetone, and with acetaldehyde that is forming the diacetyl. Diacetyl, that is a very important flavoring substances in the dairy flavors, in butter, in cheese, in flavored milk, that is present, providing some of the flavor. Further, this acetaldehyde, thymine pyrophosphate, that can be converted into acetaldehyde. Again, that is a flavoring substance. Ethanol, again, it's a flavoring substance. So these are the some of the groups of the flavorings: pyrazine, pyridine, 1,3,5 trithiene. Trithiene means 3 sulfur. Gamma pyron, thiophene, furan, you have read it in the mid course. Thiazoles, trithiolane, again containing 3 sulfur. It's a 5 ring structure, 5 carbon ring structure, pyrrole, NH group, and so on. Thank you very much. We are closing our lecture here.